First question.
Or can you first question? The first question only you were doing, or you've completed that?
Ma'am, we have done that. We started second question. We have to start.
Have to start the second question. Okay. Can you tell me which question? Can you read out the question to me? Okay, before doing the questions, let's do one thing. Let's revise all of the things we have learned in this chapter one by one. Is that okay, Munir?
Okay, ma'am.
Yeah. Hmm. So the first thing that we did was if you have if you have a circle, if you have a circle, Avni, we are revising what all has been done in this chapter till now. So if you have a circle and you have equal chords, if this and this chord are equal, then they will subtend equal angles at the center, right? So this angle is gonna be equal to this angle. So this is called equal chords. Please write this down, okay? I know you've studied this, but just write it down under revision because there are so many theorems in this that you might forget the old ones. Sorry. Equal chords subtend equal angles at the center. Then next we have the converse of this, which is if two chords subtend equal angles, then those two chords are equal, which is basically the converse of this. Okay. Then perpendicular to a chord, from center to chord, from center to a chord bisects the chord. Okay, so this also we had done. If you have a chord over here, and if you drop a perpendicular from it to it from the center, then it will bisect the chord. Then the converse of this, that the line drawn from the center to the midpoint of a chord is going to be perpendicular to the chord. So converse of this, that if a line is drawn from the center to the midpoint of a chord, then that line, the pink line, is going to be perpendicular to the chord. Then next there was equal chords of a circle are equidistant from the center. Also, tell me one thing. In the previous exercises, do you guys have any doubts? Anything you didn't understand? The classes that were taught by the other teacher? Any doubts? Anything you guys didn't understand, Avni?
Ma'am, I understood.
Okay, good. So in this, they are saying that if there are two chords which are equal, okay, they are both equal, then their distance from the center is also equal. So meaning this perpendicular distance is also equal. And the same thing is true for two different circles. If you have two different circles, let's say there's one circle over here and another circle over here, but they are the same size, meaning of the same radius, congruent circles. And if they have two equal chords, let's say like this, then their distance from the center is going to be the same. So this distance is going to be the same as this distance. Okay. This you can, how can we show this? Can someone tell me? How can we prove this? Who will tell me?
What? Prove what?
How can we prove this, what is written over here? We are given that this chord is, these two chords are equal to each other. How can we prove that these two blue distances, blue line segments are equal to each other? Okay, we'll come to this later. First, let's revise all of the theorems, okay? Fine. Then there were some uh, okay. Then if two chords are equal, then their corresponding arcs are equal. ARCS, arcs are equal, and conversely. Conversely means that if two arcs are equal, then their corresponding chords will be equal. What does this mean? This means that these two chords that we can see over here, if they are both equal, then this arc that is being made over here, this is I think I should just increase the this arc is gonna be equal to this arc. These two are gonna be equal. Okay. So we are just revising, nothing new. If at any point, however, if you feel that there's something you're not understanding or something you want me to repeat, then please by all means feel free to ask, okay? So, so basically this means that if two chords are equal, if two chords are equal, then the arcs will be equal. And we also know that if the chords are equal, then their distance from the center is equal. And if two chords are equal, then there's one more thing. The angle subtended at the center is also equal. So two chords being equal, a lot of other things also become equal. What all? Number one, the angle subtended at the center by those two chords, those two angles will be equal. Then the distance of the chords from the center, that will be equal. Then the arcs corresponding to those chords will be equal. Next theorem was the angle subtended by, please write it, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Avni,
Yes, ma'am.
were you there in all of the classes of this chapter, circles chapter, or did you miss any class?
I think I was not there in two or three, one or two
Oh,
classes.
okay. Munir, were you there in every class? Or did you miss any class? Munir, so you
Yes,
guys
ma'am.
won't, huh? Were you there in every class of this chapter, or did you miss any of the classes?
Mm. Ma'am, I missed one class, ma'am.
Okay, Riaz, what about you? Riaz,
Yes, ma'am.
I asked something.
So, I think I just missed like one class,
You missed. Okay.
one or two.
Actually, I was asking so that if any of you has done all of the classes, attended all of the classes, then I was gonna ask you for the notes so that I can see what all you guys have done. But okay, never mind then. I will just look at the recordings. Okay. So what does this mean? This means that if you take a circle over here and you angle separated by a arc at the center. So this is an arc, right? Arc basically means you just make a chord. So you make a chord like this. So angle subtended by the chord is the same thing as the angle subtended by the this arc over here. Okay. So angle subtended by it at the center. So this angle is gonna be twice the angle subtended by it at any other part of the circle. It could be like this, okay? Or it could be like this. All of these are gonna be equal, okay? This angle, or if maybe you can make it over here if you want. This angle, all of them, if this is x, then at any point over here, at any point, if you subtend that angle, it's going to be the same, x, okay? But the angle made by it at the center is going to be 2x. Okay? So this is a very important theorem. Please remember this. It is a very important theorem. Um, then we come to the next one. Angles in the same segment are equal. Segment means this part. This is one segment, right? And the rest of it is another segment. So this is kind of what I just said over here, that no matter which point you take, if you take the angle over here, that is also going to be x. I will show this to you guys, inshallah, on the graphing calculator. Okay. So angles in the same segment are equal. Then written till here, everyone? Written? Done?
Yes, ma'am.
Okay.
Yes, ma'am.
Hmm. So then let's come to the next one. If a line segment joining 2 points subtends equal angles at 2 other points, at 2 other points lying on the same side containing same side of the line containing the line segment. The 4 points lie on a circle. What does this mean? I will tell you. That means they are concyclic. Concyclic means if there are 4 points, for example, if you just take a look at 1, 2, 3, and let's say 4. Are these 4 points concyclic? No. Why? Because they don't lie on the same circle. If there are 4 points which lie on the same circle, just a minute. So, for example, these 4 points, they are concyclic. Why? Because they lie on the same circle. Okay, so that is the meaning of concyclic. So let's see what this theorem is saying. So there is a line segment. Let me try to make it a little bigger. Joining 2 points, these 2 points, subtends equal angles at 2 other points lying on the same side of the line containing the line segment. So let's say this point, 2 other points, right? So which 2 other points are we talking about? 2 other points. 2 other points. So these are the 2 other points. Line segment. So this line segment, this pink line segment, subtends equal angles at 2 other points, meaning that it subtends equal angles on this and this. So this thing subtended by the angle subtended by the pink line segment on these 2 points, they are equal. Subtends equal angles at 2 other points lying on the same side of the line containing the line segment. The 4 points lie on a circle. So these 4 points are going to be concyclic. Okay. These 4 points, let's call them A, B, C, D. These 4 points are going to be concyclic. Okay. Then if the sum of, Acha, you guys are done writing till here?
Ma'am, 1 minute.
Huh.
Ma'am.
Done? Okay. Avni, done?
I'm done.
Write it down. If the sum of either pair if the sum of either pair of opposite angles of a cyclic quadrilateral not if, sorry, please remove the if. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. What is a cyclic quadrilateral? Who will tell me? Have you guys studied this cyclic quadrilateral? Yes or no? Avni, Riaz, Munir, I think I have to call you guys one by one. Huh?
Ma'am, we have learned, but I don't remember it properly.
Okay, no problem. See, cyclic quadrilateral is nothing but the same thing which we discussed over here. Cyclic quadrilateral is, see, there are different types of quadrilaterals. Now you have trapezium, you have parallelogram, rhombus, square, rectangle, etc., kite. A cyclic quadrilateral is that type of quadrilateral which whose all of whose vertices lie on the same circle. So, for example, if this is a circle, then this I'm gonna make a cyclic quadrilateral. The vertices all lie on the same circle. Okay, so this is a cyclic quadrilateral, meaning all of the vertices they lie on the same circle. So, what does this statement mean? The sum of either pair of opposite angles of a cyclic quadrilateral is 180, meaning that if you take any two opposite angles, this angle plus this angle, it's going to be 180. This angle plus this angle, it's also going to be 180. Okay, so this plus this is 180. They are supplementary. In other words, you can say that they are supplementary. And these two are also supplementary. So the converse of this is also true. And conversely, meaning that if you have a quadrilateral, any quadrilateral, in which opposite sides are supplementary, then this quadrilateral is going to be cyclic. Okay, so can we say that a parallelogram, every parallelogram is a cyclic quadrilateral? No, opposite angles are not supplementary, na? Opposite angles are equal, not supplementary in a parallelogram. Okay. All right, let's do some questions. The first question of the exercise you have done, right? Let me read out the question. Avni, were you present in the previous class?
I joined a half of like.
Okay. Acha, tell me this. What was the last question that you did in the previous class?
1 minute, let me find mine. 1 minute.
Yeah. Yes, Avni. Okay, Munir, can you read it out, please? The last question which you have done.
Yes,
Avni.
ma'am. I only wrote the answer for the last one.
Okay. Which question is it? Did you write down the question number at least?
1 minute, I think. So let me check my text.
Hmm. Anyone else?
Oh, ma'am, I didn't write the question number. So only the
The
answer.
question. Oh, see, Avni, you should never make this mistake. And I've seen a lot of you make this mistake in your answer sheets also. You don't write the question number. So please always make it a point, whether it's your notebook or a test or whatever. Always write the question number, okay? All right, fine. Um, Acha, Avni, can you tell me which exercise?
Ma'am, 1 minute. I'm 9.4
9.4 or 10.4?
in my notebook. In my textbook, it's 9.4. Old textbook.
Old textbook. Okay, fine. So, 9.4. And how many questions are done in that exercise, Avni? How many questions have you written?
Hmm.
Hmm? Yeah. Okay, let's do a question. It's not in the exercise. Please write down this question, okay? Write it down. It's not there in your exercise, so please write it down. AB is a diameter of the circle, and CD is a chord equal to the radius of the circle. So you have the diameter AB. Let's call this center point as O. And they are saying CD is a chord which is equal to the radius. So let's say this is C and this over here is B. CD. CD is a chord which is equal to the radius. Done. Then AC and BD, when extended, intersect at a point E. So AC and BD. So this is AC. Extended, right? So we're supposed to extend it. AC and BD. So this is your BD, but you're extending it, meaning you're going even beyond. You're not stopping at D. You're going even more beyond. AC and BD, when extended, meet at a point, intersect at a point E. So this point is E. Prove that angle AEB is equal to 60 degrees. This angle. Look at the question, read the question once more. Okay. Acha, have you done this question previously? Have you done this? Because I don't know whether the other teacher made you do these extra questions or they were just doing the exercise. Huh, Avni?
Doing the exercise, not this one.
Acha, you only did the exercise questions, na?
Yeah.
Okay, fine. Fine. So, done writing the question. Shall we move ahead?
Yes, ma'am, you can move ahead.
Okay. So, what we are going to do here, first of all, let's write given, okay? Given. What all is given to us? AB is diameter and CD is a chord equal to the radius. So, CD is equal to radius. It is not equal, it is not the radius itself, but it is equal. The length is equal to the radius, okay? And AB is diameter that we can see. And that's it, that's given. We have to prove that, to show that angle AEB is equal to 60. Now, in this question, we're going to need some construction. Join, we are going to join O with C and O with D. And we are also going to join one more thing, but that we will talk about later. Okay. So join OC and OD. Done. Now, the proof. Can someone tell me what kind of a triangle is triangle OCD? What kind of a triangle is it? Isosceles. Why?
Because both the sides are equal and one side.
Which two sides are equal?
CO and DO.
CO and DO. They are both equal. And what can you say anything about CD? Is anything given about CD?
CD is a chord, no?
It is a chord, yes. But right now I'm saying he just try to focus on this triangle, okay? Oh, just a minute. Focus on this triangle and tell me, and you're right about OC and OD. They are equal. Why are they equal, Avni?
Because they're an isosceles triangle.
It is an isosceles triangle, and I asked you why is it an isosceles triangle? You said it is an isosceles triangle because OC and OD are equal. I'm
Yes.
asking you why are OC and OD equal, or how do you know that they are equal? How are OC and OD equal?
Because CD is a chord equal to the radius.
Okay, I'm asking OC, the pink line segment, the pink side, and OD, you said they are equal. How are they equal? What is the reason between them being equal? You are correct about them. I am asking why.
Why? I don't know.
Okay. They are both equal because they are both radii of the same circle, right?
Oh, yes.
Because OC is also a radius and OD is also a radius. So OC and OD are equal since since they are radii of the same circle. And this is again equal to CD. CD is also equal to both of them. Why? Because it is given that the length of CD is equal to the radius of the circle, right? So these three sides are equal to each other. That means triangle OCD is what type of a triangle? Yes, Avni?
Yes, ma'am.
So what have we just seen? That all the three sides are equal, right?
Yes.
So now can you tell me what type of a triangle is this triangle, triangle OCD?
Triangle OCD is what?
What type of a triangle is it now?
Isosceles.
Isosceles? What
Yeah.
isosceles is when only two of them are equal. Two sides are equal. Here we have all the three sides are equal to each other because all three of them are equal to the radius of the
Equilateral. Equilateral.
equilateral triangle. Very good. So triangle OCD is an equilateral triangle. Okay. And we know that in an equilateral triangle, each angle is equal to
Angle is equal to 60 degree.
60 degrees. Very good. So each of these angles is 60 degrees. So we can say that this angle over here is 60 degrees. Angle COD is equal to 60 degrees. Okay. Now what we are going to do is the remaining part of the construction, which I said we will do later, is join OC and OD, and we're supposed to join BC also. Okay. So just join BC. Join BC. Now it might be a little difficult for you, so I am going to do one thing. Look at the line segment CD. Okay. Line segment CD. This line segment is subtending an angle at the center and an angle at some other point of the circle. So the angle that it is subtending at the center is this one. Okay, this is the angle it is subtending at the center. And then it is subtending another angle at some other point. Like just now we saw over here, this one. That if there is a chord, it is subtending an angle at the center. It is going to be twice the angle subtended by it on any other point of the circle. So the same thing is happening here, that this CD of ours is subtending an angle at the center, this one, and it is subtending another angle at any other random point of the circle, which is this one. So we know that this angle over here is going to be how much? Who will tell me? This angle over here, the tiny angle. How much will it be? Can someone tell me?
Um, 30
30. Why will it be 30?
because CD is 60 and
Angle COD is 60. Yes, we just now saw that if there is a chord, let me explain it in another way. If you have a circle and there is some random chord somewhere, let's say this chord, here is the center. then the angle it subtends on the center. Why can't it just become straight line? Huh. And the same chord, if you think of some other point, the same chord subtends at some other point, any other point, is going to be half of this. So this pink angle is going to be half of the angle subtended at the center, no matter where this where this point is. This pink point is. So even if this point is somewhere over here, the angle subtended by the same chord. The chord has to be the same. The chord is not going to be different, okay? The same chord, if it subtends an angle anywhere other than the center, this angle is going to be half of the angle subtended at the center, the green angle. Understood? So the same thing is happening over here as well in the current question, that our chord is over here, right? So this point that we have is the B point is over here, and the angle subtended by this chord at this point is, again, by the same theorem, it's going to be half of the angle subtended at the center. So since the angle at the center, this one over here, we have found that this is 60 because of the fact that this is an equilateral triangle. So therefore, the angle subtended over here, the tiny angle that you can see or on the point B, that angle is going to be half of it, which is 30 degrees. So therefore, angle DBC is equal to 30 degrees, since angle subtended at center is double the angle subtended at any other point. Done till here?
Ma'am, 1 minute.
Hmm. Done?
Yes.
Okay. Acha, one more thing, maybe I forgot to mention it, but we have done this one. That the diameter subtends an angle of 90 degrees at any point on the circle. So, see, the diameter is also a chord, right? The longest chord is called the diameter. So, the diameter, it will subtend an angle. It can subtend an angle anywhere. So, even if it subtends, no matter where you pick a point, the diameter will subtend an angle of 90 degrees over there. So if you pick this point, for example, this is also going to be 90 degrees. This is going to be this angle subtended by the diameter at this point is going to be 90, no matter which point you choose. Okay, it's always going to be 90 degrees. This we had done in in the starting class itself. So, can you tell me which angle over here is going to be 90? Remember the fact that AB is a diameter. So, can you tell me which angle is gonna be 90 over here?
Ma'am, AB is how much?
AB is the diameter. So, we know that
Hmm.
angle subtended by the diameter at any point is going to be 90. So, which angle is being subtended by the diameter? Which angle is going to be 90?
Angle ABC.
ABC, think very carefully
Yeah,
about the
it will be
name of that angle. Which is angle ABC? ABC means this angle.
yeah. It won't be 90.
I am saying angle subtended by the diameter. So what is angle subtended by diameter, bache? Meaning if this is the diameter and you
Hmm.
choose at this point, then this is the angle subtended by the diameter. Not this. This is not the angle subtended by diameter.
Oh, okay, okay, okay.
This one is the angle. So now tell me, what is going to be 90 degrees over here?
Ma'am, can you scroll up a bit? Angle AEB.
But say E is not even on the circle, na? Angle subtended by diameter means that point on which it subtends the angle, that should be on the circle. Okay, let me do one thing. Let me take away all other distractions. Whoops. Now can you see, whoops, which angle is being subtended by the diameter?
ACB.
Very good. So it's ACB. So which angle is going to be 90 degrees? Angle ACB is 90 degrees. Reason? Since angle subtended by the diameter is 90 degrees. Okay, please write over here till here.
Ma'am, can you scroll down?
Yes, just a moment.
Ma'am, done.
Done. Okay. Now, let's just note down all the angles that we know of. This angle is 90. Which one? This one. ACB. This is 90. This is 60.
Ma'am,
This one
my exam date sheet came.
date sheet came. Okay. Can you send it to me on WhatsApp, please?
Yes, ma'am, I'll send it to you.
Okay. Now look at this triangle. Look at this triangle. Okay. Forget about everything else. Just look at this triangle. In this triangle, we know one angle, 30 degrees. Yeah. The other angle, we don't need this right now. I'm just going to remove it. Okay. The other angle, we know that this over here is 90. So from here to here, if this is 90, then this is also going to be 90, right? The remaining angle, they're also going to be 90. Why? Because it's a linear pair. If you look closely at just this portion, this is a line or a straight line segment, and this is another line on it. So there are two angles that are being formed. So it is kind of like this. So this angle and this angle form a linear pair. So if they are a linear pair, then their sum is going to be 180. So that means if this angle is 90, then this angle is also going to be 90. So that is what is happening here. Okay. So what can we say? We can say that this angle is 90. So just take a look at triangle CEB. In triangle CEB, there are three angles. I'm just going to make that triangle again. This is 30 and this we have found out to be 90. So can you tell me what will be this angle?
Which angle?
This one, angle CEB. CEB, this one. This is 90, na? How is it 90?
Ma'am,
We have just
60.
now seen. Very good. It's going to be 60. So there. Just a minute. I'm just writing what I just now explained. So this angle is 90. We have just now seen that. So in triangle CEB, by angle sum property, angle CEB is equal to 60 degrees. Because this is 90, this is 30. So the remaining one is going to be 60 degrees. So any doubts in what we have done till today?